Hi, everybody. This is Mr. Folly, and if I can make that, there we go. And welcome to Whoppin' Lecture number 2. Woo! Uh-oh, it's not going to let me draw. There we go. All right. So water is a weak acid. So what this means is water plus water makes H3O positive plus OH negative. So do you see how one of these waters, let's say it's this one, gave up an H positive and turned into hydroxide? That is an endothermic reaction. It is an acid because it donates an H positive. Yay! It is also a base. A base receives an H positive. So if H2O receives an H positive, it becomes H3O positive. Water is a very weak acid. That means it does not give up its H positive very easily. Its K value is called Kw, and it's 1e negative 14. That's very small. Kw is just the expression of water. So it's this expression up here, where I have products over reactants, right? So my reactants are liquids, so we leave them out. At 25 degrees Celsius, Kw is 1e negative 14. So the math says H3O positive equals OH negative equals 1e negative 7. Hey, we could do that. At 25 degrees Celsius, water is 7, neutral. At other temperatures, Kw changes and neutrality changes. So what's the definition of neutrality? Boom, equality. Oh, wow. So just to give you an idea of it, change the temperature if I'm at 40. Notice how the pH at neutral is 6.767. Notice K change. Why did K change? I thought K never changes unless you change the temperature. So just some of the fun stuff. Acids, bases, conjugate acids, and conjugate bases. We talked about that in class today, so I'm going to skip that one. I'm going to label this, though. An acid right here is the H giver. That makes this the base. It's going to be the H receiver. Okay. So in the reverse direction, this is the conjugate acid. It's got an H to give. And this one is going to be the conjugate base. It's going to receive an H. Now notice this one is kind of icky because this is a strong acid. So this one does not exist much at all. This reaction would be 99.9999999% on the left. Okay. So over here, notice how HSO4 gives an H, and HCO3 receives this right here. And on the reverse reaction, this is my conjugate acid conjugate because it's on the right. Conjugate base because it's on the right. And remember, don't be surprised if you turn that into our old friend, CO2 and H2O. All right, Ka, dissolving equation. Boom. Not dissolving equation. Acid reacting. Boom, 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 boom. Right? So, Ka is H3O positive times A negative over HA. Notice how this guy's aqueous, so it's included. Right? That is used to find the concentration of a species in solution. To measure acid strength, and that could be in the form of percent or Ka. I often find the molarity of H positive and turn it into pH. And we're going to find the percent ionization. Okay. Large Ka means a stronger acid. Large Ka means a lower pKa, lower pH. And when in pictures, a large Ka has more ions and a smaller Ka. More ions would also mean less together HAs. More ions means, instead of less, should have said fewer. That's okay. Large Ka means the conjugate has a small Kb, which means the conjugate base is very weak. Kb, same deal, right? Talked about how these are going to be our weak bases. It's going to take an H from our old friend water and make a little hydroxide. Okay. Kb, right in the same deal right here. Conjugate base from a salt. So notice if I have NaCN, conjugate base from a salt. NaCN is a salt where Na doesn't react with water, but Cn does. The ones that don't react with water are group 1 and 2 metals because they make strong acids and bases. All right, so things you should know. Kb is found from Ka. Remember, Ka times Kb equals 1e negative 14. If they give you the Ka of this, there you go. And I guess I should have just looked right there. So we're looking up here. Kb is used to find concentration of things in solution, measure acid strength, find the molarity of hydroxide to turn into pH. Could be POH, probably not. Find the percent ionization. So let's start churning through this dude right here. Uh-oh. Let me pause and get back with a calculator. Did you miss me? I didn't think so. So here we go. pKa of hypochlorous acid is this. What is the pH of a 0.1 molar solution of HClO? So remember, whenever I got Kas, I'm going to write my equation. HClO plus H2O, so he's going to react with water, gives me H3O positive plus ClO negative. Okay? So what is the pH of a 0.1 molar solution? So I'm going to start with 0.1 molar of this. 0, 0. What about water? I don't care about water because it's a liquid. Okay? So minus X plus X plus X, 0.1 minus X, X, and X. Now I do have to convert this into a Ka. So Ka equals 10 to the negative pKa. We did a lot of playing around with those equations in class today. So second log negative 7.54 is going to give me 2.88 E negative 8. So my Ka expression is H3O positive molarity times ClO negative molarity over HClO molarity. And I'll plug it in with some other weird lines. And I'll plug it in. Let's give me my weird lines. 2.88 E negative 8 equals X squared over 0.1 minus X. And let's solver that bad boy. Okay. Math. Quantity. Quantity. X squared divided by quantity 0.1 minus X. Quantity minus 2.88 E negative 8. All right, so I'm really sad now. I paused and then I came back, and I have all this stuff written down. I don't remember where I paused it, which makes me sad. I think I paused at the solver. So once I got at the solver, then I have this for the answer, and that equals H3O positive and ClO negative. Negative log that gives me my pH. Next one, notice it gives me what is the ionization of an acid, and I don't know the acid, so I call it Ha. So same basically dissolving equation, but it's not a dissolving equation. It's the reaction reacting. So you've got that deal. And now I'm going to solver this guy again. So math, 0, quantity. Whoops, put it in the wrong spot. Oop, quit go to. Second quit. Math, 0, solver, up, clear, quantity, x squared divided by quantity, 0.1 minus x, quantity minus 4 E negative 5, enter. My guess is 0.0001 alpha, enter, and I get 0.00198. 0.00198 molarity of H positive. Now, if I want to figure out the percent ionization, what I'm going to do is these are my ions, so I'm going to have 0.00198, which is my part, over my original total, which is 0.1 times 100%. So the percent ionization is the part that ionized, that's X, and then divided by 0.1. So second quit, I'm going to take X divided by, oops, I hit the wrong button, X divided by 0.1, delete the nonsense of what I hit wrong before, and I get, I guess I should be able to do that in my head, percent is 1.98%. And that is it, my friends. That is it. And to that, I will say, toodles.